Imagine a world where volcanoes erupt with such force that their plumes reach hundreds of kilometers into space. The sheer power of these eruptions is enough to send shockwaves through the cosmos, creating a spectacle that can be seen from afar. These volcanic plumes are not just a sight to behold, they are a testament to the raw, untamed energy that lies beneath the surface of this celestial body. This is not science fiction. This is a reality that exists within our very own solar system, a place where the unimaginable becomes real. This is Io, Jupiter's closest Galilean moon. Io is a world unlike any other, a place where volcanic activity is a constant and defining feature. Io is a world consumed by volcanic fury, a testament to the immense power of our solar system's largest planet. The volcanic activity on Io is driven by the immense gravitational forces exerted by Jupiter, creating a dynamic and ever-changing landscape. These eruptions are not just impressive, they are changing our understanding of volcanoes. Scientists are studying these eruptions to learn more about the geological processes that drive them, and what they can tell us about the history and evolution of our solar system. They challenge our assumptions about the forces at play within celestial bodies. The interactions between Io and Jupiter provide a unique opportunity to study the effects of tidal forces and how they can shape the geology of a moon. Io's volcanoes provide a unique window into the powerful interactions between planets and their moons. By studying Io, we can gain a deeper understanding of the complex and dynamic relationships that exist within our solar system and the incredible forces that drive them. In 1610, Galileo Galilei pointed his rudimentary telescope towards Jupiter. This was a groundbreaking moment in the history of astronomy, as Galileo's telescope was one of the first of its kind, allowing him to see celestial bodies in unprecedented detail. His observations would soon revolutionize our understanding of the cosmos. He discovered 4 points of light that moved around the giant planet. These points of light were not stars, as previously thought, but moons orbiting Jupiter. This was a monumental discovery because it provided clear evidence that not everything orbited the Earth, challenging the geocentric model of the universe that had dominated for centuries. These became known as the Galilean moons: Io, Europa, Ganymede, and Callisto. Each of these moons has its own unique characteristics and mysteries. For instance, Europa is believed to have a subsurface ocean that might harbor life, while Ganymede is the largest moon in the solar system, even bigger than the planet Mercury. Little did Galileo know that the innermost of these, Io, held such fiery secrets. At the time, he could not have imagined the volcanic activity that rages on Io's surface, making it the most geologically active body in the solar system. Io is slightly larger than our own moon, with a diameter of about 3,600 kilometers. Despite its relatively small size, Io's intense geological activity sets it apart from other moons. Its surface is constantly being reshaped by volcanic eruptions, which can reach heights of up to 500 kilometers. Its surface is a canvas of vibrant yellows, oranges, and reds, a result of the sulfur and sulfur dioxide spewed by its volcanoes. These colors create a striking and otherworldly landscape unlike anything found on Earth. The constant volcanic activity also means that Io's surface is relatively young, with few impact craters compared to other moons. This colorful landscape has earned Io the nickname Pizza Moon. The nickname is fitting, as the moon's surface, with its patches of red, yellow, and white, resembles a pizza with various toppings. This whimsical comparison helps to capture the imagination and highlights the unique and dynamic nature of Io. Among Io's many volcanoes, Loki Patera reigns supreme. This colossal volcanic depression, or patera, spans over 200 kilometers. It is home to a massive lava lake that periodically erupts, spewing molten rock and gases high above the surface. Loki Patera's eruptions are truly awe-inspiring. They can release hundreds of gigawatts of power, more than the total energy consumption of humanity. Scientists are still trying to understand the exact mechanisms that drive these eruptions and their cyclical nature. Volcanic activity dominates Io's surface. Hundreds of active volcanoes dot its landscape, creating a world unlike any other in our solar system. Vast plains of solidified lava stretch for hundreds of kilometers, punctuated by towering volcanic mountains. These volcanic features are not static. They are constantly changing, reshaped by ongoing eruptions and lava flows. Io's surface is one of the youngest in the solar system, constantly renewed by its fiery underworld. Io's intense volcanic activity is not a coincidence. It is a direct result of its relationship with Jupiter. The giant planet's immense gravity creates powerful tidal forces within Io. These forces stretch and squeeze the Moon's interior, generating immense heat through friction. Additionally, Jupiter's powerful magnetic field interacts with Io, generating electric currents that flow through the Moon's interior. This electromagnetic interaction further contributes to the heating and volcanic activity. To study Io's unique volcanism, scientists have relied on robotic emissaries. Spacecraft like Voyager 1, Voyager 2, Galileo and New Horizons have flown past Io, capturing stunning images and valuable data. These missions have revealed the sheer scale of Io's volcanic activity and provided insights into the Moon's internal structure. Future missions, like NASA's Juno spacecraft, continue to observe Io from afar. These observations are crucial for monitoring volcanic activity and understanding the long-term evolution of this fascinating moon. Despite decades of study, Io still harbors many mysteries. This small moon of Jupiter, slightly larger than Earth's moon, is the most volcanically active body in our solar system. Its surface is dotted with hundreds of volcanoes, some of which erupt with lava fountains reaching up to 250 miles high. The intense volcanic activity is driven by the immense gravitational forces exerted by Jupiter and its other moons, creating tidal heating within Io's interior. Scientists are still trying to understand the exact composition of Io's magma. The lava on Io is believed to be extremely hot, with temperatures exceeding 2,000 degrees Fahrenheit. This is much hotter than any lava found on Earth. By studying the composition of Io's magma, scientists hope to gain insights into the Moon's internal structure and the processes that drive its volcanic activity, and the mechanisms that drive its periodic volcanic eruptions. These eruptions are not only spectacular, but also highly unpredictable. Some volcanoes on Io can remain dormant for years before suddenly erupting with tremendous force. Understanding the triggers for these eruptions could help scientists predict volcanic activity on other celestial bodies, including Earth. The interaction between Jupiter's magnetic field and Io's volcanoes is also an area of ongoing research. Io's volcanic plumes release large amounts of sulfur dioxide gas, which becomes ionized and forms a plasma torus around Jupiter. This plasma torus interacts with Jupiter's magnetosphere, creating intense radiation belts that can affect spacecraft and potentially even the atmospheres of other moons. Furthermore, the long-term effects of Io's volcanic activity on its atmosphere are still being studied. The constant volcanic eruptions continuously reshape Io's surface and contribute to a thin, patchy atmosphere composed mainly of sulfur dioxide. Researchers are investigating how this atmosphere evolves over time and how it interacts with the space environment around Jupiter. And the surrounding Jovian system remain to be fully explored. Io's volcanic activity not only affects the Moon itself, but also has implications for the entire Jovian system. The material ejected from Io's volcanoes can travel great distances, potentially influencing the surfaces and atmospheres of other moons orbiting Jupiter. These questions highlight the need for further exploration and study of this enigmatic moon. Future missions to Io, equipped with advanced instruments, could provide valuable data to unravel the mysteries of this volcanic world. By understanding Io, scientists can gain broader insights into the processes that shape not only our solar system, but also other planetary systems in the universe. Io stands as a testament to the raw power and beauty of our solar system. Its fiery landscape, sculpted by relentless volcanic activity, offers a unique laboratory for studying planetary processes. By unraveling the secrets of Io, we can gain a deeper understanding of the formation and evolution of planetary systems. Io is a call to explore, to push the boundaries of our knowledge and venture further into the unknown. The future of Io exploration is bright. New missions are being planned that will provide even more detailed observations of this volcanic world. These missions will utilize advanced instruments to study Io's composition, magnetic field, and volcanic processes in unprecedented detail. By continuing to explore Io, we will unlock the secrets of this fiery moon and gain a deeper understanding of the dynamic forces that shape our solar system. The journey to understand Io is just beginning. Make sure to be there with us and like and subscribe for more mind-boggling content about space exploration. What do you think about this fiery neighbor? Share your thoughts in the comments.